This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I'm going to talk about three kinds of triangle similarity: side-side-side similarity, side-angle-side similarity, and angle-angle similarity. Let's start with side-side-side. With side-side-side similarity, we can say that two triangles are similar if the lengths of their corresponding sides are proportional. So let's see what this means. I've got two triangles here, triangle ABC and triangle DEF, and I want to see if they're similar. So here's what I'm going to do. I'm going to take a pair of corresponding sides. Looks like side AB corresponds with side DE, and I'm going to make a ratio of their sides. So side AB is 12 units long, and side DE is 8 units long. So the ratio of their sides is 12/8. Then I'll take another pair of corresponding sides. I'll take side BC and side EF. Side BC is 6 units long, and side EF is 4 units long. So the ratio of their sides is 6/4. And then I'll do the same thing with the third pair of corresponding sides. Side AC is 15 units long, and its corresponding side is DF, which is 10 units long. And now I want to see if these three ratios are equal to each other. I could do that two ways. I could reduce each of these fractions, each of these ratios, and see if they're the same. Or I could take pairs of ratios and cross multiply. So let's take a look at that because they look like fairly easy numbers to use. 12 times 4 is 48, and 6 times 8 is also 48. So that means the fraction 12/8 equals the fraction 6/4. Let's see if 6/4 equals 15/10. I'll cross multiply here. I'll multiply 6 times 10, and that's 60. Then I'll cross multiply 4 times 15, and that's also 60. So these three ratios are actually the same thing. That means the three sides are proportional. So we can say that these two triangles, ABC and DEF, are similar. I'll write that as triangle ABC is similar to triangle DEF, because we've shown that the ratios of their corresponding sides are all the same. So the sides are proportional. Let's look at side-angle-side. With side-angle-side similarity, we say the two triangles are similar if they have two pairs of corresponding sides that are proportional, and if the included angles are congruent. So here I have two triangles. I have triangle ADE, and then kind of inside triangle ADE, I have triangle ABC. Now both of these triangles share an angle. They share angle A. So I know that angle A is congruent with angle A. Now I have to see if the sides on both sides of angle A are proportional. So I'll take side AB, the length of AB is 9, and I'll start making a ratio. The corresponding side would be AD, and the length of AD is 9 plus 3 more. So the ratio of AB to AD would be 9/12. And now I'll take the other pair of corresponding sides. That would be AC and AE. The ratio of their sides is going to be 12, that's AC, and 12 plus 4 more for the length of AE. So I've got a ratio here, 9/12, and I want to see if that's equal to 12/16. I'll do this by reducing both fractions, both ratios. I can take 9/12 and divide both the numerator and the denominator by 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. And then with 12/16, I can divide the numerator and the denominator by 4. So 12 divided by 4 is 3, and 16 divided by 4 is 4. And for both of those ratios, I've got them reduced to 3/4. That means that triangle ABC is similar to triangle ADE because they had two pairs of corresponding sides that were proportional, and the included angle, this angle A here, is congruent. Angle A is congruent with angle A. Okay, let's do angle-angle similarity. With angle-angle similarity, we say that two triangles are similar if they have two pairs of corresponding angles that are congruent. So here I've got two lines, BD and CE, and these lines intersect at point A. So at point A, we have vertical angles. So I know the two angles that are formed here are going to be congruent. Angle BAE is congruent with angle DAE. And then we've also taken these two line segments and formed them into triangles by adding side BC and DE. Now, looking at the two triangles, I see they also have corresponding right angles, angle ABC and angle ADE. So I've got two pairs of corresponding angles that are congruent. The two vertical angles are congruent, and the two right angles are congruent. So these two triangles must be congruent. The two triangles must be similar. Triangle ABC is going to be similar to triangle ADE. Okay? That's it. Take care. I'll see you next time.